Hi, myself Mrs. Satabdi Dhar, and today I am going to introduce you about what is operating system. Now, in this video, we will learn about what is operating system and the evolution of operating system and all the generations, that is first, second, third, fourth generation of operating system. Next, about mainframe system, that is batch operating system, multi-programmed operating system, multitasking operating system, time sharing operating system, desktop. Next, we will learn about multiprocessor system, distributed system, clustered system, real-time system, special purpose system, open source operating system. Nowadays, near about all of us know how to use computer, and by this we all know the term OS, that is operating system, as because we all use Windows or Linux in our computers. Those are that OS or operating system. Now, what is operating system? An operating system can be defined as an interface between user and hardware. It is responsible for the execution of all the processes, resource allocation, CPU management, file management, and many other tasks. The purpose of an operating system is to provide an environment in which a user can execute programs in convenient and efficient manner. In a computer system, hardware can only understand machine code in the form of 0 and 1, which doesn't make any sense to a user. So, we need a system which can act as an intermediary and manage all the processes and resources present in the system. So, we need this operating system. Now, what is the position of operating system in this computer system? Here comes the structure. In this diagram, you can see that first come user, that is people who are using this computer. Next comes the application programs, that is compiler, database, games, video player, browsers, etc. Next comes the system programs, that is shells, editors, compilers, etc. And here comes this operating system, a special program which acts as an interface between user and hardware. And at last comes this hardware, that is CPU, memory, IO device, Now, what does this operating system actually do? The first one is process management. Process management involves various tasks like creation, scheduling, termination of process, and a deadline. It also protects the sources of each process from other methods and allows synchronization among processes. It is the job of OS to manage all the running processes of the system. Next one is process synchronization. Process synchronization is a way to coordinate processes that use shared data. It occurs in an operating system among cooperating processes. Processes have to be scheduled to ensure that concurrent access to shared data does not create inconsistencies. Now, data consistency can result is what is called a race condition. The next is memory management. Memory management is the functionality of an operating system which handles or manages primary memory and moves processes back and forth between main memory and disk and disk during execution. Memory management keeps track of each and every memory location, regardless of either it is allocated to some process or it is free. It checks how much memory is to be allocated to processes. It decides which process will get memory at what time. It tracks whenever some memory gets freed or unallocated, and correspondingly it updates the status. The next is CPU scheduling. CPU scheduling is a process which allows one process to use the CPU while the execution of another process is on hold or in waiting state due to unavailability of any resource like input output etc., thereby making full use of CPU. The aim of CPU scheduling is to make the system efficient, fast, and fair. Next is file management. Operating system is used to manage files of computer system. A file is collection of specific information stored in the memory of computer system. And file management is defined as the process of manipulating files in computer system. It management includes the process of creating, modifying and deleting the files. And the last one is the security. Security refers to providing a protection system to computer system resources such as CPU, memory disk, software programs, and most importantly, data information stored in the computer system. So, a computer system must be protected against unauthorized access, malicious access to system memory, viruses, and worms, etc. Now we will discuss about the evolution of operating system. Operating systems have evolved from slow and expensive systems to present-day technology where computing power has reached exponential speeds and relatively inexpensive costs. In the beginning, computers were manually loaded with program code to control computer functions and process code related to business logic. This type of computing introduced problems with program scheduling and setup time. As more users demanded increased computer time and resources, computer scientists determined they needed a system to provide or, or improve convenience, inefficiency, and growth. As a result, they created an operating system to process job, jobs in batches. Later, they created multitasking and time sharing to run multiple jobs and allow user interaction to improve efficiency. Multitasking brought challenges to manage input-output operations requires by multiple jobs in which vendors resolved with interrupts. Now, here we can see the first stage of evolution is batch job processing that includes linkage of library routines to program, management of files, input-output devices, and secondary storage. Next comes the multiprogramming. Resource management and sharing for multi-programs is included here. Quasi-simultaneous program execution and also single user. Next comes the multi-user or time-sharing system. Management or multiple simultaneous users interconnected via the terminals. Fair resource management, that is CPU, scheduling, spooling, mutual conclusion are included here. And the last one is real-time system, that is process control systems. Management of time critical processes, high requirements of respect to reliability and availability is included here. Now we will discuss about the generations of operating system. There are four generations in this operating system, that is first generation, which is vacuum tubes and plug boards. The second generation, transistors and batch systems. In third generation, there is integrated circuit and multiprogramming. And the last generation, that is the fourth generation, we use these personal computers. In 1940s, the operating system was first generation operating system. It used vacuum tubes for circuitry and magnetic drums for memory. It took the entire room to establish the main system. It was very expensive to operate. In addition to using a great deal of electricity, generated a lot of heat, which was often the cause of malfunctions. Computers relied on machine language, the lowest level programming language understood by computers to perform operations, and they could only solve one problem at a time, which was very time consuming. Input was based on punched cards and paper tape, and output was displayed on printouts. The UNIVAC and ENIAC computers are those examples. In 1956, the second generation operating system came. Transistors replaced vacuum tubes. The transistor was invented in 1947 but did not see widespread use in computers until the late 1950s. Transistor was far superior to the vacuum tube, allowing computers to become smaller, faster, cheaper, more energy efficient, and more reliable than their first generation predecessors. Though the transistor still generated a great deal of heat that subjected the computer to damage. It was a vast improvement over the vacuum tube. Second generation computers still relied on punch cards for input and printouts for output. Computers moved from cryptic binary machine language to symbolic or assembly languages, which allowed programmers to specify instructions in words. High-level programming languages were also being developed at this time, such as early versions of COBOL and Fortran. In 1964, the third generation computer uses these integrated circuits. The development of the integrated circuits was the hallmark of the third generation of computers. Transistors were miniatured and placed on silicon chips called semiconductors, which drastically increased the speed and efficiency of computers. Instead of punch cards and printouts, users interacted with third generation computers through keyboards and monitors. Interfaced with an operating system which allowed the device to run many different applications at one time with a central program that monitored the memory. Computers of the first time became Computers for the first time became accessible to a mass audience because they were smaller and cheaper than their predecessors. From 1971, the fourth generation computer uses this microprocessor. The microprocessor brought the fourth generation of computer as thousands of integrated circuits were built onto a single silicon chip. What is a first generation field? An entire room would now fit in a palm of the hand. The Intel 4004 chip developed in 1971 located all the components of the computer from the central processing unit and memory to input-output controls on a single chip. As these small computers become more powerful, they could be linked together to form networks, which eventually led to the development of the Internet. Fourth generation computers also saw the development of GUIs, the mouse, and handheld devices. Now, what is the mainframe system in operating system? It reduces setup time by batching similar types of jobs. Automatic job sequencing, that is automatically transfers control from one job to another. Resident monitor, that is initial control in monitor, control transfers to job. When job completes, control transfers back to monitor. Now, what are the defined types of mainframe systems? Those are batch operating system, multi-programmed operating system, multitasking operating system, time sharing operating system, and desktop, which we'll discuss now. The first operating system of the second generation computer is the batch operating system. In this system, jobs which are of similar type are grouped together and treated as a batch, as you can see in this picture. Now, they are stored on the punch card, which is a stiff paper in which digital data is stored and represented using some specific sequence of holes, which will be submitted to the system for processing. The system will then perform all the required operations in a sequence. So, we consider this as a type of serial processing. OS keeps the number of the jobs in the memory and executes them one by one. Jobs processed in first come, first served order. Each set of a job considered as a batch. When a job completes its execution, its memory is realized, and the output for the job gets copied into an output spool for later printing or processing. User interaction in the batch processing system is minimal. Once system accepts the jobs from the users and then the user is free. That is why we can use batch processing system in large organizations in these days. The batch processing system used where we want to update the data related to any transactions or any record. Transactions can be related to any customer order, receipt, involves payments, online transaction, data entry, payroll system, banks, etc. Now, this batch operating system has some advantages and also disadvantages. Advantages are same jobs in the batch are higher executed speed. A process is complete its execution. Next job from jobs pool get executed without any user interaction. Suppose a job takes a very long time, like 1 day or so, then such process can be performed even in the absence of humans. CPU utilization gets improved. To speed up the processing speed, the batch process can partition into the number of processes. And what are the disadvantages of this batch operating system? It is very difficult to debug batch system. Lack of interaction between user and operating system. Suppose an error occurs in one of the jobs of a batch, then all the remaining jobs get affected. That is, they have to wait until the error is resolved. Next is multi-programming operating system. Sharing the processor when two or more programs reside in memory at the same time is referred as multiprogramming. Multiprogramming assumes a single shared processor. Multiprogramming increases CPU utilization by organizing jobs so that the CPU always has one to execute. The following figure shows the memory layout for a multiprogramming system. The operating system keeps several jobs in memory at a time. This set of jobs is a subset of the jobs kept in the jobs pool, like job 1, job 2 to job n, as you can see in this picture. The operating system picks and begins to execute one of the jobs in the memory. Multiprogramming operating systems monitor the state of all active programs and system resources using memory management programs to ensure that the CPU is never idle unless there are no jobs to process. Multiprogramming operating system has some advantages and disadvantages. Advantages are its high and efficient CPU utilization. User feels that many programs are allocated CPU almost simultaneously. And the disadvantages are CPU scheduling is required here to accommodate many jobs in memory. Memory management is required. Next is multitasking operating system. Multitasking is when multiple jobs are executed by the CPU simultaneously by switching between them. Switches occur so frequently that the users may interact with each program while it is running. An OS does the following activities related to multitasking, like the user gives instructions to the operating system or to a program directly and receives an immediate response. The OS handles multitasking in the way that it can handle multiple operations, executes multiple programs at the same time. Multitasking operating systems are also known as time sharing systems. These operating systems are developed to provide interactive use of a program of a computer system at a responsible cost, at a reasonable cost. A time-shared operating system uses the concept of CPU scheduling and multiprogramming to provide each user with a small portion of a time-shared CPU. Each user has at least one separate program in memory. A program that is loaded into memory and is executing is commonly referred as a process. When a process executes, it typically executes for only a very short time before it either finishes or needs to perform input-output. Since interactive input-output typically runs at slower speeds, it may take a long time to complete. During this time, a CPU can be utilized by another process. The operating system allows the user to share the computer simultaneously since each action or command in a time-shared system tends to be short. Only a little CPU time is needed for each user. As the system switches CPU rapidly from one user or program to the next, each user is given the impression that he or she has his or her own CPU, whereas actually one CPU is being shared among many users. Next comes the time sharing operating system. As the name itself suggests, in a time sharing system or multitasking system, multiple jobs can be executed on a system at the same time by sharing one CPU time among them. It is considered to be a logical extension of multiprogramming because both does simultaneous execution but differ in the prime objectives. The main objective of time sharing system is to minimize response time but not maximizing the processor use, which is the objective of multiprogramming system like Unix system. This time sharing operating system has also some advantages and disadvantages. Advantages are they minimize the response time, that is greater the response time, lesser is the efficiency of the system. They reduce CPU idle time. And the disadvantages of time sharing operating systems are security and synchronization must be given a greater importance. Data communication must be enabled here. Now, the last one is the desktop system. Computer system dedicated to a single user with input devices like keyboard, mice, display screens, small printers is called desktop system. User convenience and responsiveness is very adaptive in here. It can adapt technology developed for larger operating system. Often individuals have sole use of computer and do not need advanced CPU utilization or protection features. It may run several different types of operating systems like Windows, Mac OS, Unix, or Linux. Now, what is the multiprocessor systems? Multiprocessor operating system allows the multiple processors and These processors are connected with physical memory, computer buses, clocks, and peripheral devices. Main objective of using multiprocessor operating system is to consume high computing power and increase the execution speed of system. There are four major components which are used in the multiprocessor operating system. Those are CPU, input output system, input output devices, memory unit, and input output processors. Now, what is CPU? CPU is capable to access memories as well as controlling the entire input output tasks. And what is input output processor? Input output processor can access direct memories, and every input output processor have to be responsible for controlling all input and output tasks. Now, what is input output devices? These devices are used for inserting the input commands and producing output after the processing. And what are those memory unit? Multiprocessor system uses the two type of memory modules such as shared memory and distributed shared memory. Now we are going to explain different types of multiprocessor operating systems. Now what are the types of multiprocessor operating system? There are six types of multiprocessor operating systems. Those are symmetric multiprocessor, asymmetric multiprocessor, shared memory multiprocessor, distributed memory multiprocessor, UMA multiprocessor, NUMA multiprocessor. Now the first one is symmetric multiprocessor. In this system, every processors have own identically copy of operating system, and they can make communication in between each other, in which all processors are connected each other with peer-to-peer relationship nature. It means no master and slave relation. Next one is asymmetric multiprocessor. In this system, every processor is allotted predefined tasks, and master processor has power for controlling entire system, in which it uses the master slave relationship. The shared memory multiprocessor system, each CPU contains shareable common memory. In distributed memory multiprocessor, every processor consists own private memory. UMA multiprocessor stands for Uniform Memory Access Multiprocessor, in which it allows to access all memory at the uniform speed rate for all processors. Now, NUMA multiprocessor stands for Non-Uniform Memory Access Multiprocessor. In this system, it involves some areas of the memory for accessing at the faster rate, and left parts of memory are utilized for other tasks. The next one is distributed operating system. Distributed operating system allows distributing of entire systems on the couples of center processors, and it serves on the multiple real-time products as well as multiple users. All processors are connected by valid communication medium such as high-speed buses and telephone lines, and in which every processor contains own local memory along with other local processor. According this nature, distributed operating system is known as loosely coupled systems. This operating system involves multiple computers nodes and sites, and these components are linked each other with LAN or WAN lines. Distributed OS is capable for sharing their computational capacity and input-output files with allowing the virtual machine abstraction to user. Now, what is the classification of distributed operating system? It can be classified in three areas such as client server system, peer to peer system, and middleware. Client server system is known as tightly coupled operating system. What? Tightly coupled operating system. This system is designed mostly for multiprocessor and homogeneous multi-computer. Client-server systems work as a centralized server because it provides the approval to all requests which are generated by client systems side. Server systems can be divided into two segments. Those are computer server system and file server system. Server system allows the interface and then client sends on all requests for executing as action. Finally, it sends to back response after executing action and transfer result to client. And file server system allows the file system interface for clients because their clients can be performed various tasks such as creation, updating, deletion files and more. Next one is peer-to-peer system. Peer-to-peer system is known as a loosely coupled system. What? Loosely coupled system. This concept is implemented in the computer network application because it contains the bunch of processors and they are not shareable memories or clocks as well. Every processor consists own local memory and these processors make communication with each other through various communication medium such as high speed buses or telephone lines. Next one is middleware. It allows the interoperability in the between of all applications which are running on other operating systems. With using these services, those applications are capable for transferring all data each other. The next one is clustered operating system. Clustered systems are similar to parallel systems as they both have multiple CPUs. However, a major difference is that clustered systems are created by two or more individual computer systems merged together. Basically, they have independent computer systems with a common storage and the systems work together. The clustered systems are a combination of hardware cluster and software clusters. The hardware clusters help in sharing of high performance disks between the systems and the software clusters makes all the systems work together. Each node in the clustered system contains the cluster software. This software monitors the cluster system and makes sure it is working as required. If any one of the nodes in the clustered system fails, then the rest of the nodes take control of its storage and resources and try to restart. There are primarily two types of clustered systems, that is asymmetric clustering system and symmetric clustering system. In asymmetric clustering system, one of the nodes in the clustered system is in hot standby mode and all the others run the required applications. The hot standby mode is a failsafe in which a hot standby node is part of the system. The hot standby node continuously monitors the server, and if it fails, the hot standby node takes its place. In symmetric clustering system, two or more nodes all run applications as well as monitor each other. This is more efficient than asymmetric system as it uses all the hardware and doesn't keep a node merely as a hot standby. There are many different purposes that a clustered system can be used for. Some of these can be scientific calculations, web support, etc. The clustering systems that embody some major attributes are load balancing cluster and high availability clusters. In load balancing clusters, the nodes in the system share the workload to provide a better performance. For example, a web-based cluster may assign different web queries to different nodes so that the system performance is optimized. Some clustered systems use a round-robin mechanism to assign requests to different nodes in the system. High availability clusters improve the availability of the clustered system. They have extra nodes which are only used if some of the system components fail. So, high availability clusters remove single points of failure, that is, nodes whose failure leads to the failure of the system. These type of clusters are also known as failover clusters or HA clusters. The next one is real-time operating system. A real-time operating system is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. The time taken by the system to respond to an input and display of required updated information is termed as the response time. So, in this method, the response time is very less as compared to online processing. Real-time systems are used when there are rigid time requirements on the operation of a processor or the flow of data, and real-time systems can be used as a control device in a dedicated application. A real-time operating system must have well-defined fixed time constraints, otherwise the system will fail. For example, scientific experiments, medical imaging systems, industrial control systems, weapon systems, robots, air traffic control systems, etc. Now, what are the components of real-time operating system? The components are the scheduler, symmetric multiprocessing, function library, memory management, fast dispatch latency, user-defined data objects and classes. The terms used in real-time operating systems are task, job, release time of a job, execution time of a job, deadline of a job, processors, maximum it is the allowable response time of a job. There are two types of real-time operating system. Those are hard real-time systems and soft real-time systems. Hard real-time systems guarantee that critical tasks complete on time. In hard real-time systems, secondary storage is limited or missing and the data is stored in ROM. In these systems, virtual memory is almost never found. Example is medical critical care system, aircraft system, etc. Now, soft real-time systems are less restrictive. A critical real-time task gets priority over other tasks and retains the priority until it completes. Soft real-time systems have limited utility than hard real-time systems. For example, multimedia, virtual reality, advanced scientific projects like undersea or undersea exploration and planetary rovers, etc. There are various classes of computer systems based upon their computational speed, uses, and hardware. The following are some special purpose systems according to specific applications. They are a real time system and a multimedia system. A real time system is a computer system that requires not only that computed results be correct but also that the results be produced within a specified deadline period. Results produced after the deadline has passed, even if correct, may be of no real value. For such systems, many traditional operating system scheduling algorithms must be modified to meet the stringent timing deadlines. Now, a multimedia system must be able to handle not only conventional data such as text files, programs, and word processing documents, but also multimedia data. Multimedia data consists of continuous media data like audio and video as well as conventional data. Continuous media data such as frames of video must be delivered according to certain time restrictions, for example 30 frames per second. The demands of handling continuous media data require significant changes in operating system structure, most, most notably in memory, disk, and network management. The last one is open source operating system. Open source operating systems are released under a license where the copyright holders allows others to study, change as well as distribute the software to other people. This can be done for any reason. The different open system operating systems are like Cosmos. This is an open source operating system written mostly in programming language C Sharp. Its full form is C Sharp Open Source Managed Operating System. Till 2016, Cosmos did not intend to be a fully fledged operating system, but a system that allowed other developers to easily build their own operating systems. It also hid the inner workings of the hardware from the developers, thus providing data abstraction. Another open source operating system is FreeDOS. This was a free operating system developed for systems compatible with IBM PC computers. It provides a complete environment to run legacy software and other embedded softwares. It can boot it from a floppy disk or USB flash drive as required. It is licensed under the GNU General Public License and contains free and open source software. So there is no license fees required for its distribution and changes to the systems are permitted. The next one is Gnode. Gnode is free as well as open source. It contains a microkernel layer and different user components. It is one of the few open source operating systems not derived from a licensed operating system such as Unix. It can be used as an operating system for computers, tablets, etc. as required. It is also used as a base of virtualization, inter-process communication, software development, etc. as it has a small code system. Another one is Ghost OS. This is a free open source operating system developed for personal computers. It started as a research project and developed to contain various advanced features like graphical user interface, C library, etc. The Ghost operating system features multiprocessing and multitasking and is based on the Ghost kernel. Most of the operating system in Ghost OS is done by C++. Next one is ITS. The Incompatible Time Sharing System was developed by the MIT Artificial Intelligence Library. It is principally a time sharing system. There is a remote login facility which allowed guest users to informally try out the operating system and its features using ARPANET. It also gave out many new features that were unique at that time, such as device independent graphics terminal, virtual devices, inter machine file system access, etc. Next one is OSV. This was an operating system released in 2013. It was mainly focused on cloud computing and was built to run on top of a virtual machine as a guest. This is the reason it doesn't include drivers for bare hardware. In the OSV operating system, everything runs in the kernel address space and there is no concept of a multi-user system. Another one is Phantom OS. This is an operating system that is based on the concept on persistent virtual memory and is code oriented. It was mostly developed by Russian developers. Phantom OS is not based on concept of famous operating systems such as Unix. Its main goal is simplicity and effectiveness in process management. Hope by this video I can make you understand about what is operating system and its introductory details. In my upcoming video, I will discuss with you about the structures of operating system. Thank you.